Welcome to Unit 4 of the Intermediate Functions course. In this unit, you're going to build on the report you created in Unit 3. We'll dive into some new functions that will help you optimize and enhance your data analysis skills. By the end of this unit, you'll have mastered the most common string and array functions, enabling you to tackle more complex tasks with ease. While some cases might be unique, don't worry, you'll find more in-depth discussions on those in future courses. Feel encouraged to explore and experiment with various functions as you progress. Let's jump right in and start enhancing your skills. Welcome back. As you dive into this section, you have a choice. Continue with the scenario you've been working on, or start fresh with a ready-made template. This unit focuses on adding a list of the top 3 selling stores to your final report. The starting point here is streamlined thanks to optimized and condensed functions, which means you'll be working with a smaller, more efficient setup. The template you can use includes a powerful module called Generate Report Single Module. This combines the functions from previous steps into one cohesive formula. The output will be familiar, mirroring the final result of your last unit. This streamlined approach not only simplifies your workflow, but also highlights the power of nesting functions into complex formulas. As you proceed, you'll get a deeper explanation of how to effectively utilize these tools. In this scenario, we're focusing on assisting Sharmila with the final segment of a report. Our primary task is to generate a comprehensive list of the top 3 stores across all regions, based on their revenue. This process involves several key steps that integrate and optimize various functions. We begin by parsing data from 2 store sources, which involves extracting and organizing the relevant information. Once that's set, we'll merge these store lists to create a cohesive data set. The next step is crucial, sorting the stores according to their revenue. This sorting will allow us to identify the top performers effectively. Following the sorting phase, we isolate the top 3 stores from this list. It's not just about finding these stores, but also about extracting and organizing their names and figures for the final report. This final report is then composed using a single streamlined module which simplifies what could otherwise be a complex task. Lastly, the completed report is prepared for distribution, ensuring that all stakeholders can access this crucial financial insight. This scenario not only helps Sharmila, but also underscores the importance of streamlined data management and reporting in business operations. As you assist Sharmila with the report's final stage, you'll be working on combining data to identify the top performing stores. This involves using the set variable feature within the tools module to merge 2 separate store arrays. By bringing these data sets together, you're setting the stage for further analysis. Merging these arrays helps ensure that you have a comprehensive view of all the stores and their revenues, which is crucial for generating accurate insights. This step is a foundational part of sorting and ranking the stores effectively, paving the way for a focused look at the top 3 performers across all regions. In this part of the project, you're diving into the task of sorting stores by revenue to identify the top performers. Think of it as organizing data to create a clear picture of which stores are leading in different regions. By sorting the revenue data, we streamline the process of pinpointing the top 3 stores. This way, the most successful stores appear right at the beginning of our sorted list. It's like reorganizing your bookshelf so that your favorite books are at the front, making them easy to find. This approach simplifies our task and ensures that Sharmila can easily generate the report she needs, focusing on the best performing stores across all regions. In this module, you're tasked with assisting Sharmila by identifying the top 3 stores by revenue across various regions. Imagine sorting through a broad list of stores, a bit like ranking competitors in a race. You'll streamline the data, ensuring only the leading contenders are left standing. This approach not only makes the report more precise, but also saves Sharmila time. By narrowing the list, you highlight the key players, providing clear insights that can drive business decisions. You're effectively transforming a complex data set into a concise, actionable summary. Now that you've identified the top 3 stores, Sharmila just needs their names for the final report. This module will streamline your data, focusing on just those names. By doing so, we eliminate any unnecessary information, making it easier to generate a clear and efficient report. This step is crucial in ensuring Sharmila receives precisely what she needs without the clutter. It's all about simplicity and precision at this stage. Let's dive in and see how we can easily achieve this streamlined outcome. Now that we have identified the top 3 stores based on revenue, the next step is to format this data into a clear and organized list. This final step is crucial for Sharmila's report as it transforms raw data into an easily digestible format. Our goal here is to take the store names we've gathered and arrange them neatly, which will streamline the report creation process. This not only helps in presenting the information clearly, but also ensures that stakeholders can quickly grasp the key players in each region. Let's move forward with crafting this list to make Sharmila's report both comprehensive and professional. Let's dive into creating the list of the top 3 stores through a streamlined approach. If you're starting from the provided template, you'll notice it follows the same logic as before, but with some configuration tweaks. This time, instead of breaking down different steps across multiple modules, we're combining all the necessary functions into one large formula within the Generate Report single module. This method is efficient because it reduces the number of operations by avoiding the use of multiple set variable modules. Think of it as a more compact and powerful way to achieve the same outcome. It's like building a sleek, innovative machine that gets the job done faster and with less complexity. Embracing this technique not only aligns with optimization tips from earlier, but also speeds up the process during this exercise. As we move forward, ensure to meticulously follow each step to ensure accuracy and consistency in your results. By doing so, you'll create a seamless list of the top performing stores, ready to enhance Sharmila's report with valuable insights. To start building a list of the top 3 stores, we'll begin by merging our store data into a single array. First, you'll add a new module called Set Variable from the tools. This action will allow you to handle the data more efficiently. Once you've set up the module, give your variable a clear name, such as merged_stores. Naming your variables descriptively helps keep your project organized and makes it easier to understand later. In the variable value field, we're using the merge function. What this does is combine the arrays from 2 separate stores into one cohesive array. Make sure to separate these arrays with a semicolon. Also, don't forget to complete the function with a closing parenthesis. By executing these steps carefully, you'll ensure that your data is prepared correctly for further processing. This will be essential when we sort and analyze the information to display our top performing stores. To generate a list of the top 3 stores by revenue, we'll make use of the sort function. This function is highly flexible, allowing you to order the elements in a variety of ways. For our purpose, we'll focus on sorting by revenue in descending order. Let's break down how to use this function. First, identify the array you want to sort, in this case, the merge stores array. The sort function includes an order parameter, which lets you specify how you want the data organized. You have several options like ascending or descending order, and even case-insensitive sorting. For revenue, we'll use DESC, which stands for descending. This ensures that the store with the highest revenue appears first in your sorted list. The key argument allows you to access specific properties within complex objects. This is useful when your array elements are more complex data structures, such as objects with multiple attributes. By defining a key, you point the function to the exact piece of data you want to evaluate, in this context, the revenue. Remember, in programming, arrays are usually zero-based, meaning the first item starts at index 0. However, for sorting and listing purposes here, think of the first item as index 1. So when you're selecting the top 3 stores, you'll be looking at positions 1 through 3 in your sorted results. Ultimately, sorting by revenue in descending order will give you the top performers right at the top of your list. Aim to set this up on your own, and in the next steps, we'll refine the solution together. Now that we're generating a list of the top 3 stores, let's focus on organizing the data efficiently. We've chosen to use the variable name sorted stores for clarity. This variable will hold the results once we've sorted the list of stores by revenue. To achieve this, we're using the sort function. Specifically, we'll sort the merged underscore stores array. By specifying desk for descending order, we ensure that we're listing stores from highest to lowest revenue, allowing us to quickly identify top performers. Remember, the key factor we're sorting by is revenue, which tells our function exactly what data point to prioritize. The variable has a lifetime of 1 cycle, meaning it will be active just long enough to accomplish our task. This keeps our process efficient and clean. This approach provides a clear, logical pathway to highlight the standout stores based on financial performance. To extract the top 3 stores from your sorted list, we're going to use the slice function. Think of the slice function as a way to cut a smaller segment out of a larger array. In this case, we want just the first 3 items, which represent the stores with the highest revenue. To do this, we'll start by using the slice function on the sorted stores array from the previous step. You'll begin your slice at position 0, where arrays start counting, and you'll slice all the way to position 3. This effectively selects items at positions 0, 1, and 2. Here's how you type the command. Start with the word slice, followed by an open parenthesis. Then map the sorted stores array and specify the positions 0 to 3. Finally, close the parenthesis. This simple slicing technique focuses your output so you can easily see which stores are leading the revenue race. In programming, it's crucial to understand how to manipulate both arrays and strings effectively. Here, we're focusing on the substring function, which extracts parts of a text string. The substring function requires 2 parameters, the start and end positions. It's important to remember that the start position is inclusive, which means it includes the character at that index, while the end position is exclusive, leaving out the character at that index. Now, you might notice that this is quite similar to the slice function we discussed before, used for slicing arrays. While slice is perfect for arrays, substring is designed for strings, allowing you to easily extract portions of text. Let's apply this understanding to prepare for our exercise, ensuring each step is clear before moving on. Imagine you have an array filled with objects representing different stores. Now your task is to extract just the names of the top 3. To achieve this, you'll want to recall a specific function we've discussed extensively. Can you guess what it is? The goal is to transform these objects into a simpler array containing only the names. Think of this function as a tool that allows you to reshape your data effortlessly. Once you've isolated these names, the final step is straightforward. Join them together to create a cohesive list. This will ensure your report is clear and concise, ready for presentation. To create a list of the top 3 store names from a complex array of objects, we'll need to use the map function. This powerful tool allows us to transform each store object into a simpler format, just the names. Start by accessing each store object with the key store name. Mapping helps us extract these names efficiently, turning them into a straightforward array of strings. With this step completed, you'll have a cleaner, more focused data set to work with, setting the stage for building an easy-to-read list in the next step. Remember, mapping is like harvesting exactly the data you need. Now that you have your array of store names, the next step is to efficiently transform them into a readable list. This is where the join function comes in handy. Think of join as a way to seamlessly glue together all the elements of your array into a single string with a specific separator of your choice. It's essentially the counterpart to split. While split breaks down a string into an array, join does the reverse, merging an array into one cohesive string. To create an organized and aesthetically pleasing list, consider using a new line along with a dash or star as separators. This approach not only keeps the list tidy, but also enhances readability. It's a simple yet effective method to ensure your top store names stand out clearly in the report. By understanding these concepts, you're well on your way to mastering data manipulation for effective communication. Congratulations, Sharmila, on completing an outstanding report. Here's a quick summary of the highlights. The total revenue is an impressive $58,702.77, and Dwayne has topped the charts as the leading salesperson. Now let's dive into the list of the top 3 stores. We've got F Make, followed by Makes and Noble, and finally Maker and Booker. These results showcase the success of your strategic efforts. Your attention to detail has not gone unnoticed, making a remarkable impact in such a short time. Your bosses are thrilled and you are already in the spotlight for a potential promotion. Keep up the amazing work. This is just the beginning. Now that we've seen Sharmila's excellent work on generating the list of top bookstores, let's explore a few handy tools she didn't get to use in her report. These functions can be incredibly useful for data manipulation and optimization. First, the **add** function. Imagine you have a list of items and you realize you need to include an additional piece of information. This function allows you to seamlessly add new elements to an existing array, which can be particularly helpful in scenarios like appending new tags to database entries. Next is **deduplicate**. When dealing with large data sets, duplicates can skew your results and lead to incorrect analyses. This function ensures that only unique entries are considered, streamlining your data processing and improving accuracy in your reports. Finally, the **distinct** function. This is essential when you want to extract only the unique values from your set, helping you focus on the diversity within your data without redundancy. While Sharmila didn't use these in her current project, they offer powerful ways to refine and simplify complex data scenarios, making future tasks more efficient. Let's take a closer look at the add function. This is a versatile tool that allows you to effortlessly add a new item to an existing array. While the merge function combines 2 entire arrays into one, add is perfect for when you need to append just a single value, whether it's a simple piece of data or a more complex structure. Imagine you're managing an online store and you need to tag all products processed through a specific system called Make. By using the add function, you can easily include a Make tag to every relevant product. This not only helps in organizing your inventory, but also simplifies filtering new records. To use add, you can follow a straightforward example. If you have an array containing the numbers 1, 2, 3, and you want to add the number 4, employing the add function would transform your array into 1, 2, 3, 4. This simplicity makes add a handy function for day-to-day tasks involving arrays. Let's talk about the deduplicate function. This handy tool is perfect for when you need to ensure all values in an array are unique. Imagine you've accidentally added a tag twice to your list. Deduplicate easily removes the extras, leaving only one instance of each value. What makes deduplicate particularly versatile is that it works both with simple arrays, like a list of numbers, and complex ones, such as arrays containing objects. However, keep in mind that for objects, both items must be entirely identical to be considered duplicates. Consider an example where a tag make is repeated. By using deduplicate, it's removed, resulting in an array free of duplicates. This can be incredibly useful when you're processing items but need to avoid duplicate tags, perhaps due to constraints or errors. This function ensures your data remains clean and organized, facilitating smoother operations and analyses. Let's dive into one of the handy functions Sharmila couldn't cover, called distinct. This function is all about streamlining arrays by removing duplicates. What's special is its ability to focus on specific properties within complex objects. By using the key argument, you can target exactly what you need to match. If you're dealing with nested properties, the dot notation comes in handy. Remember, arrays start with an index of 1, so be mindful of your starting point. While we won't unpack all its possibilities here, you can experiment on your own to see how it fits your needs. For those who love exploring, check out related functions like add and deduplicate. And don't forget to revisit the first module to uncover some magical methods for generating simple arrays from scratch. Enjoy the discovery. Congratulations on completing the unit. You've taken great strides in understanding and applying these functions. While there's always more to explore, you now have the foundational skills to start experimenting on your own. By playing with these functions, you'll discover new perspectives on problem solving and potentially cut costs by avoiding unnecessary modules. Functions often offer a cleaner, more efficient approach. They empower you to create scenarios more rapidly and address unique challenges that might not be possible with modules alone. Before wrapping up, take a moment to check your understanding with our review segment. This will set you up nicely for the intermediate assessment ahead. Keep exploring and innovating. You're doing fantastic.